Somewhere, in the cold darkness of the far future, the last remnants of an ancient civilization cling to existence, their golden age long since past, their sprawling interstellar empire now reduced to whispers among the stars. The universe around them is dying. Stars have flickered out, galaxies are drifting apart, and silence reigns supreme. But in the shadow of a black hole, they've carved out a final refuge, a shell of demolished worlds encircling gravity's last lighthouse. And within this shell, they've discovered something more precious than all their past achievements: time. It was the black hole, paradoxically, that gave them life's final gift. Not warmth, not light, but the ability to stretch moments just a little longer. Deep in the well of gravity, time itself slows. While billions of years pass outside, they experience only days, perhaps hours. This was their final engineering miracle, not to escape death, but to delay it, to linger a little longer in a universe that has already begun to forget them. This is not a fantasy, it's a story rooted in physics, in Einstein's vision of time, space, and the strange ways they bend around gravity. But what is time, really, and what is space? They're so familiar to us, constants of our existence, yet under the surface, they're riddled with mystery. We move through space, we live through time, but do we truly understand them? When Einstein proposed that space and time were not absolute, that they could stretch, twist, slow, and accelerate, he shattered the comfortable Newtonian view that had endured for centuries. According to Newton, time ticked forward like a cosmic metronome, uniform and eternal. Space was simply the stage on which matter performed, but relativity revealed a deeper reality. Space and time are one fabric, space-time, and this fabric is dynamic. It curves in the presence of mass. It ripples like a pond when disturbed by massive objects. It is not the backdrop. It is it is the play itself. But this realization only deepens the mystery. If space and time are part of the same fabric, what is this fabric made of? Is it a substance, like the air we breathe or the water we drink? Or is it purely mathematical, a description of how matter moves and interacts? Philosophers have been wrestling with these questions for millennia. In ancient Greece, Aristotle argued that empty space was impossible. Space, he said, was defined only by the objects within it. Centuries later, Newton would flip this idea on its head, suggesting that space was absolute, existing even in a universe devoid of matter. And then came Einstein. His equations told a different story. Mass and energy deform space-time, creating the effect we perceive as gravity. In the presence of a massive object, like a star or a planet, space-time bends, and objects follow these curves, not because they're being pulled by a force, but because they're following the straightest possible path through a warped geometry. And time, too, bends with space. A clock on a mountaintop ticks ever so slightly faster than one in a valley below. This isn't science fiction, it's measurable, it's been tested on airplanes, satellites, and even in your smartphone's GPS. Still, the strangeness persists. If time can slow, what defines its direction? Why do we remember the past, but not the future? Why does a glass fall and shatter, but never reassemble and leap back onto the table? The universe's fundamental laws, surprisingly, don't care which direction time flows. A movie of two colliding particles looks the same whether played forwards or backwards. But on the scale of stars, galaxies, and human lives, time has a clear arrow. That arrow, it turns out, is defined not by gravity or relativity, but by entropy. Entropy is a measure of disorder, and the second law of thermodynamics tells us it always increases. Heat spreads, stars die, memories fade. This progression toward greater disorder is what gives time its apparent direction. We are, in a sense, riding a one-way escalator toward chaos. The mysteries of the universe. But here's where the mystery deepens again. At the beginning of the universe, the Big Bang, entropy was incredibly low. The universe was hot, dense, and remarkably smooth. Why? That's one of the great unsolved questions in physics. Why did the universe begin in such a highly ordered state, only to tumble downhill into disorder? Was it chance? Or was there something fundamental about the fabric of space and time that made it so? Some physicists believe the answer lies in information, not in the objects we see, but in the relationships between them, the patterns, the logic, the code. And like entropy, information can be erased. When a computer deletes a file, it releases a tiny amount of heat. This is not a flaw. It's a law. It's the cost of forgetting, and perhaps forgetting is essential to time itself. Could the passage of time be the universe's way of discarding information? Of choosing what to remember and what to leave behind. Eve. This brings us back to space-time, not as a smooth, continuous fabric, but as something granular, perhaps even digital, at the smallest scales, below atoms, below quarks, below anything we can currently observe. Space and time may be made of discrete units, like pixels on a screen. This is the realm of quantum gravity, a place where Einstein's curves meet the fuzziness of quantum mechanics. And in this world, space and time may not exist at all in the way we understand them. Some theories suggest that space and time are emergent, illusions born from deeper, more fundamental interactions. In the same way that temperature emerges from the motion of molecules, space might emerge from entangled information. We don't walk through space. We navigate a web of relationships. And what we perceive as space is simply a convenient way to map those relationships. In this view, time too is an emergent property, a measure of how states of information change relative to each other. And if true, this would mean that space and time are not the bedrock of reality. They are shadows cast by something deeper, something stranger, something we have only begun to glimpse. And yet, even as science pushes the boundaries of understanding, we are haunted by paradoxes. The block universe model, derived from relativity, tells us that the past, present, and future all exist simultaneously, that time is a static dimension we merely traverse. If true, free will might be an illusion. Our choices may be pre-written in the structure of space-time, as immutable as the positions of the stars. But we don't experience time this way. We feel the passing of moments. We remember, we anticipate, we act. Perhaps this experience, this sense of now, is the most fundamental thing there is. Perhaps consciousness is what breathes life into space-time. Or perhaps it's just another byproduct of entropy and computation. In the end, we return to our dying civilization at the edge of a black hole. They harnessed time, they mastered space, but they could not outrun them, for even black holes evaporate, releasing their mass in a slow drizzle of radiation, fading into the void. And when the last one blinks out, when the final particle decays, what will remain? The unknown future awaits us. What lies beyond the edge of our understanding? It's a mystery that beckons us to explore, to question, and to imagine. Will there be another universe, a new kind of time, a rebirth of space? Or will there be silence? We don't know, but we do know this: space and time, as strange and elusive as they are, have guided every step of our journey. They cradle the stars, they sculpt galaxies, they shaped us. And even if they are illusions, even if they are masks worn by deeper truths, they are, for now, the only compass we have in a universe that is still unfolding. And that might be enough.